You wake up. Something is wrong. Your body feels like it's being crushed into the mattress. Your arms won't lift. Your legs won't move. You think you're having a stroke. You're not. Overnight, without warning, Earth's gravity increased 10 times. And in the next 15 minutes, you're going to watch the planet you live on destroy everything on its surface, including you. The human body was not designed for 10 times Earth's gravity. At 1 g, your heart pumps blood effortlessly. At 10 g, it can't. Your cardiovascular system would need to work 10 times harder just to push blood to your brain. In the first 30 seconds, most people lose consciousness. The blood drains from your head. Your vision goes black. Fighter pilots experience this in jet turns. They call it G-lock. Gravity-induced loss of consciousness. They have a few seconds. You have no warning. For the elderly, the sick, children under 5, the first minute is fatal. But here's what makes it worse. You can't call for help. Your phone has tripled in effective weight. Lifting your arm requires the effort of a heavy deadlift. Even breathing becomes a battle. Your lungs compress. Your ribs struggle to expand against the force pushing down on your chest. At 10 g, every breath is like breathing with a 200-pound weight on your sternum. The world's fittest humans might survive the first hour. Barely. But the planet itself won't. While humans collapse, buildings follow. Modern architecture is engineered for exactly 1 g of gravitational load. Structural codes. Load-bearing calculations. Foundation depths. All designed for a world where gravity stays constant. At 10 g, every structure on Earth is suddenly carrying 10 times its design load. Steel buckles. Concrete cracks. Foundation sinks. The first structures to go are skyscrapers. Their height becomes a fatal liability. A 100-story building at 10 g experiences the same structural stress as a 1,000-story building at 1 g. No building was ever built for that. Within 20 minutes, the world's skylines begin folding. Not dramatically like in movies. Slowly. With a groan. Floor by floor, compressing downward like a telescope collapsing in on itself. Then bridges. Suspension bridges fail first. Within 30 minutes, global infrastructure is in cascading collapse. Power lines snap. Water towers implode. Dams fracture. Every water supply on Earth is compromised within the first hour. And underneath the surface, something far worse is beginning. At 10 g, the planet itself begins to change. Gravity is the sculptor of worlds. It determines mountain height, ocean depth, atmospheric density. At 10 times normal force, everything Earth has built over 4.5 billion years begins to collapse inward. Mountains first. The Himalayas, currently 8,800 meters high, could not exist at 10 g. Within 24 hours, the great mountain ranges begin to subside. Everest loses kilometers. As mountains fall, the tectonic plates beneath them shift. A cascade of magnitude 8 and 9 earthquakes. Every coastline on Earth gets a tsunami within hours. As the crust compresses, the mantle below heats up. Pressure and heat. The two ingredients for volcanic activity. Within 18 hours, every dormant volcano on Earth reactivates. Not just the known 1,500 active volcanoes. The ones we thought were dead forever. All firing. Simultaneously. Sound familiar? Now let's talk about the oceans. At 10 g, water is still water, but it's 10 times heavier. The waves that once rolled gently onto beaches now crash with the force of concrete walls. Increased gravity compresses the atmosphere. Atmospheric pressure at sea level would increase toward 10 atmospheres. That is the pressure found 90 meters underwater. Simply standing at sea level would feel like being submerged in the ocean. There is no high ground. There is no escape. But here's where it gets interesting. Because life, in its most fundamental form, is stubborn. We know this because high-gravity planets exist. Super-Earths, planets 2 to 10 times Earth's mass, are the most common type of planet in our galaxy. Speculative evolution models show what life under high gravity would require. Lower center of mass, wider, shorter bodies, denser bones, stronger cardiovascular systems. Trees on a high-gravity world can't grow tall. They grow wide. Forests would look like carpets. Animals would evolve to hug the ground. Flying, as we know it, becomes impossible. Birds vanish. The biodiversity of Earth, 8.7 million species, would be reduced to whatever can survive the pressure. Estimated survivors, less than 1% of current species. The reset button of evolution, pressed without warning. Now, the question you're actually asking. Could this happen? Earth's gravity is determined by its mass. For gravity to increase 10 times, Earth's mass would need to increase dramatically. That means a collision. Or a capture event. A rogue planet, drifting through our solar system. It sounds impossible. But rogue planets outnumber stars in our galaxy. Recent astrophysics research suggests there may be 100 billion rogue planets in the Milky Way alone. Somewhere, in some solar system, this scenario has already happened. And whatever was living there, never saw it coming either. 10 times more gravity, and civilization ends in hours. But what happens when we go in the opposite direction? What if gravity didn't just weaken? What if it disappeared entirely? No gravity. Zero. Everywhere on Earth. All at once. The answer isn't freedom. It's something far more terrifying. That video drops next. Make sure you're subscribed. Because once you see what happens in the first 60 seconds, you won't look at the ground the same way again.